Okay, welcome back to a new topic in the syllabus. Topic 3, Stoichiometry, looking at formulae. Remember to press like and subscribe when you're watching these videos on YouTube. Thank you very much. Here we go. Your learning outcomes, of course, state the formulae of elements and compounds named in this subject content. Define the molecular formula of a compound as the number and type of different atoms in one molecule, and deduce the formula of a simple compound from the relative number of atoms present in a model or as a diagrammatic representational picture. Here's the questions I pose to you. Can you write a chemical formula and give the name of that element or compound? Maybe you can, maybe you can't at this stage, but if you can, great. Given the chemical formula, can you name that element or compound? You might name some common examples of water, for example, or methane, or hydrogen gas. Can you write the chemical formula and the name and give me the appropriate labeling? Can you write the correct chemical formula simple compound presented as atomic model or in diagrammatic representation? Okay, let's go to the next slide. Okay, writing names of chemical formulae. Here is the basics that we should go through. Elements are represented by symbols derived from their names. For example, hydrogen represented by capital H, oxygen, capital O, and carbon, capital C. Remember, elements are made up of only one type of atom. Here we've got compounds. Compounds consist of two or more elements chemically combined. And remember, there are different elements. For example, you've got here water with the formula H2O and carbon dioxide CO2. We're looking at writing names and formula for compounds, especially what a molecular formula of a compound is. So it provides information about the composition of one molecule of a compound, and it indicates the number and types of different atoms present in the molecular formula. For example, here we've got H2O, and you can see there are two hydrogens and one oxygen atom. So you can see there's two there represented and then oxygen there. Now we're going to be looking at the deduction of a compound formula. They can be deduced from diagrams, models, or diagrammatic representation. So here's a model that shows the arrangements of a compound, looking at them different forms, either the ball and stick method or two-dimensional method. For example, we're looking at examples relating to the covalent molecular compound of water. You've got H2O here. Here we have the classic deduction formula example here. We've got a model of water, and you can see here this is represented by oxygen, and then you've got your two hydrogens here, one and the second hydrogen here. There's the classic formula H2O. Remember, the subscript on the right hand side represents the number of hydrogens. Notice there's no, you can have a 1 there if you like. It hasn't got any numbers there, it means one of them. Let's have a look at the next one, and we've got another example here, deduction chemical formula with a model. We've got a nice ball and stick three-dimensional model here of methane. So you can see here these represent hydrogen, and this represents carbon. And you can see it's in this particular structure. We call it a tetrahedral structure for your information. Tetrahedral. CH4, commonly known as methane. Next diagram representation coming up. But before we do that, remember the formula of an element is represented by its symbol or chemical symbols. The molecular formula of a compound indicates the number and type of atoms in one molecule. And the last bit here that we've been looking at, the formula of a compound can be deduced from the relative numbers of atoms in a model or diagram representation, as seen in the models of water and methane. Let's have a go at a quick 3, see if you absorb that information again and how well you've done. Remember, do the best you can And if you don't get it the first time, please go through the video many times or PowerPoint presentation as you like. What is the formula for sodium chloride? Is it A, B, C, or D? Write down your answer. Pause the video if you need. Question 2, which of the following represents the molecular formula of methane? Is it A, B, C, or D? What do you think? Pause, write down your answer. On to the next questions. Question 3, what does the molecular formula of a compound represent? Is it A, the total number of atoms in a compound, B, the arrangement of atoms in a compound, C, the number and type of atoms in one molecule of a compound, or D, the charge of a compound? What do you think? Write your answer down. Pause the video, write it down on a piece of paper. Next question. Sorry, it's not a quick 3, it's actually a quick 4. How can you deduce the formula of a compound from a model or diagrammatic representation? What do you actually have to do? Is it A, counting the total number of atoms in a compound, B, by analysing the arrangement of atoms in a compound, C, by observing the relative numbers of atoms in connection to the model, or B, by determining the charge of the compound? What do you think? Choose your answer to number 4. Here comes the answers. Please have a go at writing them down, part of your learning process. Here are the answers. Answers coming up now. See how well you've done. Here we go. Number 1 was NaCl, that's the formula for sodium chloride. Number 2, the chemical symbol formula for methane is CH4. You can see 1 carbon and 4 hydrogens. 3C, the number and type of atoms in one molecule of compound, the definition, and then diagrammatic or model representation by observing the relative number of atoms and their connections in the model. Observing means looking using your eyes. Hope you enjoyed this video. Remember to subscribe and press like. Thank you for watching Macbeth Achieve Your Potential.